Hello everyone. Welcome to another episode of Deep Dive Knowledge. Hello. I would love to learn more about your work on the semantic kernel and how it functions as an AI orchestrator. Could you please explain the main purpose and objectives of the semantic kernel?
The main purpose of the semantic kernel is to serve as an AI orchestrator. It acts as an essential layer that connects various components of an AI application, including language and learning models, LLMs, external sources, and systems. The semantic kernel utilizes a set of connectors and plugins to facilitate this connection. The objectives of the semantic kernel include 1. Resource management. The kernel manages the resources required to run code in an AI application. This includes handling the configuration, services, and plugins needed for both native code and AI services to run together effectively. 2. Integration. The semantic kernel enables the integration of LLMs with other components, both internal and external. It provides the means to connect and interact with these components seamlessly. 3. Orchestration. The kernel plays a crucial role in orchestrating the flow of information and tasks within the AI application. It coordinates the execution of different functions and services to achieve the desired outcomes. 4. Contextualization. By utilizing semantic memory search, the semantic kernel enhances the contextual understanding of the AI application. It leverages memories to store and retrieve information that adds broader context to the application's decision-making process. Overall, the semantic kernel aims to provide a comprehensive framework for managing and integrating LLMs and other components in an AI application. It enables efficient resource management, seamless integration, effective orchestration, and enhanced contextualization.
That's fascinating. It seems like the semantic kernel plays a critical role in connecting and coordinating various components within an AI application. Could you explain how the kernel connects these components, especially the language and learning models, LLMs, in order to achieve the desired outcomes? How does it ensure smooth integration and orchestration between these different components?
Certainly. The semantic kernel acts as the AI orchestration layer that connects and coordinates the components within an AI application, including the language and learning models, LLMs, to achieve the desired outcomes. The semantic kernel utilizes a set of connectors and plugins to connect the LLMs and their related components, as well as external sources and systems. These connectors and plugins enable the semantic kernel to manage resources necessary for running the code in an AI application. When it comes to coordinating the LLMs, the semantic kernel uses semantic functions and native functions. Semantic functions allow the kernel to understand the user's intent and context by analyzing the input query or request. Native functions, on the other hand, enable the kernel to perform specific tasks directly without relying on external services. To achieve the desired outcomes, the semantic kernel works in a goal-oriented manner. It starts by analyzing the user's query and identifying the desired goal. For example, if a user asks for the best Italian restaurant in Milan, the semantic kernel will use its semantic functions to understand the intent and generate a list of Italian restaurants in Milan, based on the user's preferences and requirements. The kernel then applies various algorithms or techniques to rank the results and present the most relevant options to the user. This coordination and integration of LLMs, connectors, and plugins within the semantic kernel enable it to generate intelligent responses and perform complex tasks. In summary, the semantic kernel connects and coordinates the components within an AI application, such as LLMs, using connectors and plugins. It uses semantic and native functions to understand user queries, analyze context, and achieve the desired outcomes through goal-oriented processing.
Thank you for the detailed explanation. It's intriguing to see how the semantic kernel combines semantic functions, native functions, connectors, and plugins to facilitate seamless integration and coordination of the language and learning models, LLMs, within the AI application. Could you expand on the role of the planner within the semantic kernel? How does the planner orchestrate these components to achieve user goals? What kind of strategies or mechanisms does it employ to ensure efficient orchestration?
The planner plays a crucial role within the semantic kernel by orchestrating the components to achieve user goals. Its main responsibility is to generate plans or sequences of actions that will be executed to fulfill the user's query or task. To achieve this, the planner employs several strategies and mechanisms for efficient orchestration. It starts by working backwards from the user's goal, breaking it down into smaller sub-goals or tasks. The planner then uses its semantic functions and native functions to determine the necessary actions and components required to accomplish each sub-goal. The planner also takes into account user preferences and constraints to optimize the plan generation process. It can rank and prioritize different options based on various criteria, such as user feedback, availability, or relevance. This ensures that the most suitable actions and components are selected to achieve the desired outcome. Furthermore, the planner leverages its ability to dynamically select and configure plugins or components from its plugin library. This allows it to adapt and customize the plan generation process based on the specific requirements of the user's task. By utilizing the appropriate plugins, the planner can perform actions like retrieving information, making reservations, or scheduling events. Overall, the planner within the semantic kernel employs a goal-oriented approach, breaking down user goals into manageable tasks, considering user preferences, and dynamically orchestrating the components to efficiently achieve those goals. This process ensures that the semantic kernel can generate effective plans and provide relevant and accurate results to the user.
That's fascinating. It's impressive to see how the planner within the semantic kernel takes a goal-oriented approach and breaks down user goals into manageable tasks. By utilizing semantic functions, native functions, and dynamically selecting and configuring plugins, the planner orchestrates the components efficiently to achieve those goals. In terms of implementation, could you explain the programming languages that developers can use to build AI applications with the semantic kernel? What are the advantages of using these specific languages? And are there any limitations or considerations that developers should be aware of when using them? With the semantic kernel,
developers can use multiple programming languages to build AI applications with the semantic kernel. The semantic kernel supports a range of languages. It's important to note that the choice of programming language depends on various factors, including developer expertise, project requirements, existing codebase, and ecosystem support. The semantic kernel offers flexibility by supporting multiple languages, allowing developers to leverage their existing skills and choose the language that best fits their needs.